Hey everyone, so this is what's inside your Arduino kit. Everybody should have this in front of them at some point. I'm just going to talk about what's here and tell you that the board itself, this little bag with the IC chips, and the LEDs are the ones you should be most careful with. Try not to drop them, try not to discharge any static on them. If you can touch something metal to kind of discharge any built up static before you start handling this stuff, that would be well advised. So no wool sweaters taken off beforehand and then playing with this stuff. Just discharge your static, then start opening these things. We're going to start with the board itself, the USB cable, and the breadboard, just to start setting things up. So let's start by talking about the board itself. The board itself has a number of in-out pin headers here that we can use to access and manipulate different things digitally through the code. They're all labeled on the sides pretty clearly. And the ones we're only going to concern ourselves with to begin with are the ones over here under the power section. We're going to use this essentially like our battery and draw from the 3.3 volt and ground as our positive and negative points to our breadboard. We're using 3.3 because that's about the voltage that our LEDs are going to take without needing a resistor, thankfully. And that's going to be our positive, our ground. Any one of these, either of those grounds, can be our negative, and we're going to hook those to the breadboard with jumper cables. But first we have to power it. To power this, we're going to hook up our USB cord to our computer. We don't need to be in the Arduino program. We don't even need to be writing any code, anything like that. We just need to plug it into a computer via USB. Now we have our Arduino powered. We've ran the 3.3 volts source to the hot red rail of our breadboard, and one of the two grounds to the negative. Negative and ground, the same thing in a DC application. All I want you to do is simply grab one of the green, red, and blue LEDs and identify the negative side, which is the short leg, and drop those just directly into these rails. Because it's only 3.3 volts, we don't really need a protective resistor. It's very low voltage. The reason I say to grab a green, a blue, and a red is that the yellow need more than 3.3 volts, so they won't light. And by jamming these all directly into the rails, we're creating a parallel circuit, powering them all simultaneously. No one is dependent upon the next, as in a series circuit, which is what we'll create next. Okay, so here we've set up a simple series circuit. We're still drawing from the 3.3 volt source on the Arduino board. And I have two red LEDs in series. So in this configuration, the long leg of the upper LED is in row 1. And the short leg is in row 4. The lower LED, the long leg, is also in row 4, so those two are connected. And the short leg is in row 8. That row is also shared by this jumper going back to the negative side of our rails. So the short leg is the negative side. That side points towards negative. In the first row, sharing with that same leg is another little jumper, just going back to hot, completing the circuit, making sure it goes through entirely. Each component, each LED, is dependent upon the one in front of it to transmit the power through. That's why it's a series circuit. We're making a little loop here from positive to negative. And you can kind of see they're pretty dim. Each one takes about 1.2, 1.5 volts, so we're just at the bare minimum of what they want. If we switch our power source on the board from the 3.3 to the 5 volt, that will get significantly brighter. Because now they're both getting 2.5 volts, each one in this series. So we're kind of overvolting them a little bit, but that's alright for now. If I remove either one of these, they'll both go out, sort of like Christmas lights. But what you never want to do is run just one of these off of the 5-volt source. That's too much voltage. You'll damage the LED. It might pop on you. So be careful. So what we've got set up here now is another series circuit with a resistor in the series to a red LED. I'm still drawing now from the 3.3 volt source. That's still powering the red side of our rails, and the ground is still going to the negative side. I'm using jumpers to connect between and through the resistor. This is the light dependent resistor you're going to find in your little baggie. It's got long legs and a little flat surface, kind of shiny, 2 little points. And we're going to be using jumpers to just move the power between it and the LED. The long leg on this upper side, because that points towards the hot side. The short side of the LED, the short leg, is being connected back to ground with this little jumper. Now the reason we're doing this configuration and the reason this is so far away is so that over here we can block the light and dim the LED with a physical motion. So this is one way of getting some input into an LED, into the computer, ultimately. But this is just a fun way to manipulate an electric circuit. And I highly recommend trying it with different LEDs and different source voltages. You'll see you can run more in a series from the 5-volt source versus the 3-volt source. In parallel, you can run a fair amount of them, 3, 4. So try different configurations to set up how this variable resistor that's controlled by light can affect one or multiple LEDs. So I've set up another series circuit with an LED and a push button so that we can control the LED with a physical button press. There's a few buttons in your little kit. It's important to know how they work. If we're looking at it from the side, you'll see the kind of curled tips. They kind of curl in, rather than from this side they're fairly straight. Looking at them from this orientation, these 2 points are connected electrically. The switch does not disconnect these 2 points. The switch disconnects between these 2 parts of the switch. It's kind of tricky. So whatever you hook up electrically, these should be in different rows of the breadboard, because this, between these 2 points, is the disconnect that this switch operates on. So here we're coming from hot to one side of the switch. This particular is in row 5, or 6, I'm sorry. The other side of the switch is in row 8, which is where the long leg of the LED lives. The short leg of the LED lives in row 12, and that gets jumped all the way back to negative so that we complete the circuit when we press the switch. So try making up as many of these as you can with as many switches as you have, and always connect it back to the 3.3 volt source so that we're not going to run the risk of overvolting our LEDs with the 5 volt. So 3.3 volts is what's running on the hot. Don't run any singular LED off the 5 volts yet. So here I've set up 3 buttons and 3 LEDs. Each one is a series circuit onto itself. So there's the red series circuit, the green, and the blue. Every one of them has a jumper wire leading from the hot to one side of the switch, leading to the long leg of the LED, going through the LED to the short leg back to the negative side of the circuit. So that's one series circuit, and there's one of those for each one of the colors of LED. So now I can kind of start to use these buttons as interactive methods to make some stuff happen. You notice one at a time they work, and they should work when you push them all. So any combination. And if you've ever heard of an RGB LED or an RGB screen or an RGB anything, it's 3 LEDs, red, green, and blue, mixing in different variations to create one combined color. So this is sort of a simplistic mode of trying to visualize that. Okay, everyone. So this is what you'll see when you open up the Arduino program once you have it installed. Reference the videos that I'm sending along to help you with your installation. This is the basic sketch platform, and this is what we'll be using to interface with the Arduino. Up here, what we want to start with is under Tools. We're going to select the board and make sure it says Arduino Uno. That's the type of board we're using, and that our port is highlighting a USB port that has the Arduino Uno on it. This is my Bluetooth port, so I know it's not that. You may have multiple ports on your computers, but find which one. It may say Arduino Uno. You may have to try a couple different ones, but you'll find the right one soon enough. Once those are all the right settings, we can go up to the file and open an example sketch. There's plenty of built-in examples made by the designers to help us understand this. If you go to Basics and Blink, it'll open up a new sketch. Everything at the top that's in gray is meaningless to the computer itself. It's just information for us humans. The computer doesn't read it. When it's between the /* combo, that's telling the computer to ignore it. This is what the designers are telling us, and I'll show you how to set this up once we upload it to the board. Down here are the two major parts of any piece of code for the Arduino: our setup, which is what gives the board itself some initial guidelines, and the loop. This is what will run infinitely as long as we have it powered up. So now that we have this sketch on our screen, we've got our Arduino plugged in and the correct USB port selected. We can go over here to the Upload button and hit Upload. You can watch at the bottom, it'll say compiling, uploading, and it'll tell us when it's done. And when it's done uploading, then we can start to build our circuit around what this program does. So here's the circuit set up on the breadboard for the Blink sketch. What I've done is, if you've read the gray matter up at the top of the sketch, pin 13 is the pin that's controlling our LED. So I'm running a jumper wire from pin 13 to the long leg of the green LED. The short leg is going through a single 220 ohm resistor back to the negative rail, and I'm using another jumper to bring that to the ground that's located on this side of the board. There's lots of grounds and they all go to the same place. So what the Blink sketch does is it tells the microcontroller, the Arduino board, to turn this light on for a second, off for a second, on for a second, off for a second, ad nauseum, until it loses power or the world ends or the LED dies. That's what the void loop is all about. It just repeats and repeats and repeats. We can set up different circumstances inside that repeating loop to make different things happen. That'll be for next week. I'm going to show you just a little bit more coding differences so we can talk about how to change the particulars of this little bit of code to make it a little bit fancier, and try to play with some more LEDs in a couple more fashions. Okay, so we're back in the code now. Looking at the top, at this gray matter up at the top here, it's telling us a little bit about what the code does. It mentions pin 13. Pin 13 is the onboard LED. So when you say onboard LED, it's always referring to pin 13, and that's the built-in LED that they're talking about here. This blue lettering, when you see something blue like this in an Arduino code, that's something special. It's a variable that means something to the computer. This means pin 13. We could also say pin 13 here in a different way rather than saying LED built in. We're going to leave it at that for now. And what I'd like you guys to try doing is just manipulating these two numbers to be very different numbers and see what it does to the code and to the LED as it's blinking. Essentially, these are milliseconds, thousandths of a second. How many thousandths of a second on, high? How many thousandths of a second off, low? Manipulating these numbers will change how long it's on, how long it's off. If you so desire, you can copy this and paste it, making sure it's within the curly brackets of the loop, and manipulate these numbers to be completely different sets of numbers as well, to be very, very different. You could do 40 and 4,000. We can just make this a really random array of numbers and see where that goes. Once you have it all changed, making sure that you're respecting to be inside of these curly brackets, because that's what the loop is. It happens inside these curly brackets. We can upload it and see what it does to the LED. So as you've manipulated these, you'll start to see your LED blinking in various patterns, various ways. And just keep playing with this. Keep changing those numbers, seeing what it does, copy and pasting, and seeing what kind of different patterns you can make. Can you make Morse code? Can you make something weird happen? Who knows? It's all very fun. Okay, now that you've had a little bit of time to play with one LED blinking with some pretty pre-made code that you didn't have to think about too much, let's dig into what the code means just a little bit with a slightly more advanced bit of blinking code that I've crafted here. I'm going to include this in the email so that you guys can just copy paste it into the Arduino program and play with it yourself. Let's talk about the components. We still have a setup loop and a void loop, but above it we have three things here, three integers. The int is a shorthand for integer, telling that the computer is about to receive a variable that stands for a whole number. These integers, LED red, LED blue, and LED green, correspond to three different numbers, which are going to be the three different pins on our Arduino board. Every line of code inside of the program needs to be separated by a semicolon. You see each one of these lines has a semicolon at the end. The same thing inside setup and inside loop. Semicolons basically tell the computer, hey, go to the next line of code. It's a period on that sentence, as it were. In our setup here, what we're doing is we're using this special word called pin mode. And that pin mode takes two arguments inside of these parentheses. It takes a variable, in this case the pin number, represented by this variable, and it tells the computer what it's going to be. It's telling us that LED red, which means pin 8, is going to be an output, not an input, an output. So it knows it's going to be sending signals out of that pin. The same thing with LED blue, pin 10, and LED green, pin 13. These are all output pins. And in our loop, this is where we get to play with these variables. Instead of having to say pin 13, we just say the red one, the blue one, the green one. And these functions, much like pin mode, digital write tells the computer something very specific. It's telling us to digitally, meaning either on or off, high or low, tell the red LED to go high, meaning turn on. So that pin 8, the LED red pin, is now going to be the source of our positive voltage. So that's going to turn high for half a second, and then it's going to go low for half a second, and then move on. It's going to read this like a paragraph. It's going to turn the red one on for a half second, off for a half second. The blue one on for a half second, off for a half second. The green one on for a half second, off for a half second, sequentially. So once we upload this to the board, we should be able to then set up our circuit and have this operate in a pretty interesting way, and then we'll be able to manipulate these numbers and have this pattern change to our liking. So here's the circuit that I've built from that previous set of code, with the red, blue and green LEDs being on and off for half a second each. So each one of these is a series circuit onto itself, starting at the pin that we've designated in the code and ending back at the ground rail at the breadboard, so that they all share a common ground back to the board. We only need one jumper back to ground here. And each one's protected by a 220 ohm resistor. And so if we start to go back into the code, manipulate the on-off delay times, that delay function telling us how long it stays into that high or low state, we can start making these blink in all sorts of fun and fancy ways. So here's an example of taking all of those 500 millisecond numbers and changing it to 50 milliseconds. So we're fractionally decreasing the amount of time these things are on and off, and so they can run real fast. Just as a quick example of a fast manipulation to those numbers and that difference that makes. So keep playing with this, keep trying different combinations of numbers, different combinations of LEDs, and see what you come up with. And here's a slight variation on that code where by changing the order of which LED is lighting up in which time, it seems like the light's bouncing back and forth between them, side to side, instead of just running in one direction. Just different thoughts on how to manipulate light and the sense of motion coming out of this thing. So that's pretty well it for this week. I highly recommend that you guys keep changing numbers, changing variables, experimenting with different LEDs in different positions, making sure you understand how to use the breadboard, how to use the Arduino and control its different pins and those pin functions of digital writing high and digital writing low. If you run into any problems where things just inexplicably won't work, first make sure that your diodes are in the right orientation. The short legs are towards negative. Secondly, try to make sure that your rows, all your jumpers and all of the ends of your LEDs are in the same row that you're trying to connect them in. Sometimes they can be off by one and that ruins everything. So double check those before moving back into the code to make sure all the code is correct. Usually it's just a simple manipulation of pins in the right and wrong places. Again, if you have any problems, always reach out, let me know. I'm interested to see how this goes for you guys. Please don't hesitate, and please stay healthy.